Today, we are going into the deep end of networking layer to talk about service mesh. This is part of my System Design Essential series. The goal here is to give you a solid mental model of system design topics. We're breaking down service mesh concept, Istio, and Linkerd today. This is a concept first introduction to help you build your system design foundation quickly. If you want to see a deep dive on the trade-offs or a specific case study, let me know in the comments. No fluff, let's get into the technicals. Why do we need a mesh? Because microservices without one quickly collapse into network chaos. Think of it like a busy airport without air traffic control. You run into the loop, where aggressive retries turn a tiny blip into a cascading outage. You find the dead end, where missing timeouts tie up resources forever. You have the open padlock, where someone inevitably forgets to secure a path with TLS. And finally, you have the black box, where it's impossible to debug because you lack distributed tracing. The runtime simply doesn't give you distributed networking for free. The core solution is a physical separation of business logic and network governance. This is the key conceptual shift. In a monolithic world, networking was after an afterthought. In a mesh, we remove messy, repetitive, high risk networking code into an application itself. We push retries, load balancing, and encryption into a shared infrastructure layer. This allows your application to act like a normal app again, focusing entirely on the business logic, while the mesh handles the plumbing. How does this actually work? Through the Sidecar Proxy. This standardizes the network boundary across every programming language. Whether you're writing in Go, Java, or Python, the Sidecar enforces policies, emits metrics, and terminates TLS without a single line of code modification in your app. We aren't teaching your app new tricks. We are simply changing the physical path the traffic takes. However, be aware of the Sidecar Tax. Deploying a proxy in every pod means multiply CPU and memory overhead across your cluster. The architecture relies on a strict separation of the data plane and the control plane. Think of it as isolating the brain from the brawn. The control plane is the brain. It computes policy and pushes configuration centrally. The data plane is the brawn. It consists of the sidecar proxy that handles live traffic interception and routing. A critical design feature here. If the control plane dies, the data plane survives by using the last known configuration. The mesh isn't a framework, it's a governance layer. Let's look at the heavy hitter, Istio. It provides heavy-duty enterprise control and deep traffic shaping. Built on the Envoy proxy, Istio is incredibly expressive. It uses components like virtual services and destination rules to split traffic, mirror requests, or inject faults or chaos engineering. It's the engine of choice for zero trust MTLS. One caveat though, Istio has a massive configuration surface area. It gives you all control you could ever need, but easy to misconfigure if you aren't careful. On the other side, we have Linkerd. If Istio is an engine, Linkerd is a precision scalpel. It's a focus entirely on simplicity and low overhead. It uses a custom Rust-based proxy built specifically for the mesh, providing predictable latency and memory shift. Linkerd gives you a zero config MTLS right out of the box. It's not a Swiss Army knife. It purposely stops you from building overly esoteric routing rules to keep the complexity as low as possible. Choosing between them is about trade-offs. Envoy-based Istio wins on feature richness and deep control, but has a steeper learning curve. Linkerd wins on simplicity, efficiency, and low friction. When you're making this decision, never ask which is better in the abstract. Ask which trade-off your team is willing to manage at 2 a.m. during a production outage. Do you need a Ferrari engine or you are a reliable scalpel? One of the most powerful features of Mesh is traffic splitting. It turns deployment risk into a manageable math problem. Instead of flipping the switch for the whole system, you can route 90% of the traffic to your stable version and 10% to a canary release. You watch the telemetry, and if it looks good, you gradually open the valve. Remember, splitting stateless traffic is easy. but splitting traffic that mutates state requires extreme care. The mesh also protects you from yourself with circuit breakers and retry budgets. Retrying blindly turns a transient blip into a self-inflicted DDoS attack. A circuit breaker detects when a downstream service is failing and flips to open to let it recover. It uses half-open probes to test for recovery without flooding the dependency. Retry budgets ensure that you only retry what you can afford, making failures local, visible, and survivable. Security and observability are the final pillars. MTLS ensure a default posture of zero trust. Both sides of every internal connection must prove their identity. The control plane handles certificate rotation automatically so you don't have to. On the observability side, proxies emit request level telemetry. When latency spikes, the mesh stops you from guessing, is the service alive? And tells you exactly which downstream dependency caused the spike. The future of this space is the ambient mesh. This optimizes overhead by physically dissolving the sidecar. It splits responsibility between node level security and service level L7 policy. This allows you to achieve mesh benefits without paying the full per pod sidecar tax. Platform engineering is an endless cycle. Build an abstraction to solve a problem, then ruthlessly optimize the cost of running that abstraction. The golden rule of microservices is to standardize the boundary and isolate the logic. The service mesh is simply the physical separation of application logic from the network logic. Don't force your developers to be network engineers. Standardize the boundaries, govern the traffic centrally, and let the infrastructure do the heavy lifting. Now, for the question of the day, in your current stack, are you finding the sidecar tax worth the benefits? Or are you looking towards ambient mesh to solve the overhead problem? Let me know in the comments below. Don't forget to like, share, and subscribe, and visit the site for full deep dive. See you